me introduce myself. I'm Bruce Ashfield. This is the why we're laughing. This is the second time I've tried to give a very similar talk. Last time I set the low bar for inability to have audio or video work, and this time we look like we're doing better already. Um, what I'm going to talk about is sort of building and deploying containers in meta-virtualization, of which I am the maintainer and have been working on for probably 8 or 9 years now. So yeah, Trevor, you will have to count me down because I can see no clock, and I have not just you can if you yell out when there's 5 minutes left, I can accelerate if I'm taking too long. So
Okay, you've got about 40 minutes until the
how
next
long?
talk. Well,
40.
it's a 30-minute talk and then there's a break. So, if you run
All right,
long,
I'll try to keep it. Yes, I was
yeah.
gonna say I'm like I double space this to make sure I hit the page limit. um, the I'm gonna cover some goals of the talk. I'm gonna give a brief history of meta virtualization. I have a little technology timeline that I'm gonna go over, and then yeah, whatever. We'll just hit this as we go. It's not you can all read what this is. Maybe the last two parts are actually of the most interest, which is past and current. Um, how we build and deploy them and sort of where we're going at, or where that's the royal we, where I'm hacking and meta virtualization to go in the future. So, oh my goodness, another one. We don't need this. All right, overview. So meta virtualization has been around for a long time, hence the name virtualization, because it was mainly centered around virtual machines initially. But we're using the loose definition of containers as a system level virtualization if you want to fit into the naming. But it started in June 2012. There's more commits than that, and there's more contributors than that because I wrote this slide last fall when I did the summary. But you could consider meta virtualization as that integration point for the different types of virtualization technology. So we have virtual machines, containers, we have the core technology, which I would consider at this point, KVM, well, KVM's in the kernel, bad example, Zen, or a container runtime like runc, for example, and variants. Those are the core technologies, plus the supporting software. So you'll see in my technology timeline, a definition of supporting software would be everything from the networking plugins to the configuration to some package lists and things around deploying a containerized system. It does try to serve many audiences in the sense of I'm always chasing new integrations and new tools as well as things that are established, and you'll see them kind of come and go and fade in my technology timeline. But very little has actually been turfed from the layer completely. We still have a lot of the original things. Um, it's the layer is tested. It passes the Octo layer check now and is tested by the auto builder, which is good. And it should be stable, meaning we don't break it for very long. It does need some better CI, and hence why I'm doing a talk with John Mason shortly about CI, CD, and some options that I'll bring in there. Because right now the CI and testing is me building and running and working on things, and it we're hitting the breaking point for scalability. Um, and of course, the recipes have migrated over time because I actually have several other container sort of layers that I maintain, and I migrate more things into meta virtualization, and we will hopefully migrate some things out of meta virtualization over time into core, for example. Here is the technology timeline. So you can see in 2012, we started with, LXC as the containerized solution because, well, that's all there was. Um, KVM and Zen and libvirt and some simple management tools around um, those things. And then apparently we didn't work for 2 years, do anything. Those are the dark ages of meta virtualization. And now we've been adding more things as time goes on. So, Docker appeared as, that one big container runtime that everybody wanted, which of course almost immediately split into what is now called Docker CE Community Edition, and I created a Moby recipe to get the open source bits of it. And now actually Docker CE, if you will, if you check the latest meta virtualization, has adopted how we were building Moby all along, which is kind of interesting. But then Docker, so right about here where containerd and runc appear, that's where the runtimes and the CNCF started to kick up, and the container runtime, the CRI, was split out, and there was these different interfaces for the runtime and the management. So that's when runc appeared. We added containerd, and then the OCI image specification showed up. So we got the OCI tools and Cryo for being able to manage them directly. And I started integrating sort of Kubernetes as a management stack platform for the containers, and as well as runv and kata containers, which are they're sometimes called safe and secure containers, where they're VMs that behave, that can be managed like containers, but they are virtual machines. And you'll see the star I have around kata because it's actually been sort of broken for 2 years. And I haven't bothered to fix the build because nobody's mentioned that it's broken. So patches accepted if you'd like kata containers to work again. And then in the last little while, even more things have been added. The ability to generate an open container image type was added around 2019. We added management tools, Scopio, and then the Red Hat sort of competitors to some of the command line runtime tools. Podman has appeared. We have crun, which is a C implementation of runc. And then just recently, Xvisor, which is another hypervisor, runx, which is actually Xilinx does quite a bit of work with this, I should say, but it is similar to kata containers and runv. It's secure containers using Zen as the engine behind it, and that does actually work. And we've added K3s. That was about a 4-month integration window to get it working, but it does work, and I just upgraded again in Master Next. And finally, you can see just recently I've migrated Maki or Maki or UMOC, however you want to say it, because I'm changing the way that some of the container backends work, and it's an option that I'll have available shortly. And Nerd Control, which is a better way to interact with containerd, and it is showing how badly we need fixes to the Go fetcher because I have 42 git fetches in the recipe to avoid Go mod fetching during the build phase, but that's a completely different talk. So that's the technology timeline. And Trevor or whoever, if somebody wants to interrupt me with a question, we don't need to save them to the end either, because I'm talking fast. And
so far so good.
All right, good. So anyway, that's all the stuff we have. So yeah, it's more than virtualization and KVM by a long shot. I won't go into this in too much detail because I covered quite a bit of it, but I would say that there are now more solutions and choices than ever before. The big thing is some of the complexity is increased when you get into, that's why it took so long to get K3s up and running, because you now need to not just integrate the container runtime or LXC or KVM. There is networking configuration. You have to interact with systemd. There's package groups. There's all sorts of things that need to be coordinated. And as it turned out, the issue with getting K3s to work was runc needed to be built with seccomp enabled, or you had terrible subtle errors and no containers would start. And that was the debug for that. So, but what we need still is even more, working on more system level configuration and flexibility. I created some CNI networking classes to handle the networking side, but we need a little bit more ability to split out the CRI, which is the container runtime interface, and different parts of it that can be selected in and out. We need some more ability to choose those, but of course that increases the test matrix. So there's a little bit of give and take there. And of course, some of the plumbing and tools and the image creation assists have been added, but more are needed. And that's actually something that I'm currently working on with, you'll see in my final slides. So, this is the slide, that the question that we sometimes get, and I spend a lot of time answering off and on to different audiences, is, why the Octo project in containers? Isn't it all about the application, what you're running. Why would you care from building it all from the open embedded Yocto ecosystem? And this is where I did an update to the slide that we were talking about yesterday at the open embedded developers meeting. That the building from Yocto and doing your containerization that way, it solves problems that you don't know you have yet. Think licensing compliance, think reproducibility, think uh, security updates, and of course, and then it's evolving. Think be able to generate a software bill of materials. Um, if you're just pulling off Docker Hub, you really get none of that without adding a whole lot of tooling and things around it. So, yeah, you can pull from Docker Hub and run something quickly, but I hope you're not shipping that as your product. Is my advice. Um, we've only ever used sort of been standards compliant and compatible in the sense of jumped onto Open Container Initiative, that's sort of the day it appeared, and started attempting to build and run the lowest level containers with runc. So we've always tried not to be a Docker layer, and it's been all the other compliant and standards container runtimes that have been in there. And the big thing is it's about building block technologies. So the choice needs to be there. We're not trying to pick winners and losers. It's not all about runc versus Docker versus containerd versus Podman, right? We don't want to pick your container runtime. Everybody has their reasons why they do it, they don't want it, but we would like you to be able to change over time what you do. So we don't want to pick it for you, and then we don't want to lock you in. And of course, flexibility, so you can pull different layers and have meta-virtualization interact with different parts of the ecosystem. And of course, the big advantage of Yocto project in anything is hopefully you can, if you need to, you can either do your own fine-grained configuration and tuning for performance, footprint, whatever it is that you really care about in the tuning. All right, I don't even know how long I've been. 1:30. Okay. So build and deployment. I'm going to spend a minute talking about that. So for our purposes, this is one of those things you'll find if you dig into the container world. There's a lot of kind of overridden, reused, and similar terms. So for my purposes, when I'm talking about build and quote unquote deployment, for build, it's the compilation and construction from source of the container or the fetching of open embedded built artifacts. And you'll see why I care about that bracketed one later. And deployment is installing a container on the target or into an image. Again, that matters because it's not just about Docker pull or fetching from a repository at runtime. We need to be able to, in many cases, have these containers installed into an image and be runnable on first boot. So those are the definitions I'm going to work with for the next section. So for container build, again, as I said, this talk is not a tutorial. It's not a how-to in that sense. There's better talks out there that you can find in over time about exactly how you might want to create your own container images and how they work. And we actually are trying to bring some more of those references into Metavirtualization, or again, that's the royal we, I am. But OE core has the base support. Meaning that container image type and the ability to construct the images and everything. That's all that's all OE core, and that's where it belongs. And the techniques to actually construct your container, they've changed and evolved over time. It used to be when I was doing this, it was sort of iterative and multiple builds, and then you would take the deploy directory and we would sort of build up a container image from a tarball or from the different parts, and we would construct the container images using those artifacts. And still valid, it's still something you might want to do. We now have the ability to do multi-config builds. So you can build different parts of the container, multiple different configurations, have them depend on each other, have it build, and then assemble sort of all in one pass versus multiple builds and assembly. So that helps a bit. And then there's this OCI image type, which constructs a, image is a bit of a strong word for it. It's the properly formatted directory structure that you can run with the OCI tools, or that you can use Scopio, say, to copy directly to a Docker Hub repository, whatever repository you want. So it can construct that directly in the deploy directory. So the point of the container build is that it leverages the core values, it embraces them and uses them. It does not replace or duplicate or replicate things that are done in core. We're still good for questions?
So far, so good.
In
You've
case
got
you wonder
about
why I'm looking that way, Trevor, you're to the right hand of my screen, so I can see your picture.
you're, you got 13 minutes left. Lots of
All
time.
right, container build challenges. I can't say I like it. I just find it's sort of, I find it a bit, we had a big discussion. Oh, by the way, you can join us. I'll plug right now. We had a discussion about a week and a half ago on the Metavirt channel, which is now on the other chat networks and Freenode, so you can find it there. But we talked about the different ways that the recipes, how you basically need to have an application recipe, and then a containing recipe, and then another recipe just to build a single application. And then to build yet another application, you have to do the same thing. So if you're building 10 different applications, you could end up with 20 different recipes, right? So I find no matter what method you use in my list of ways to build containers, I find them all somewhat clunky and somewhat confusing. Maybe I'm just not bright enough to figure it out, but I don't find it particularly end user friendly. It'd be nice to just say, I want to put this other recipe foo, I want it in a container, and you're done, right? And that's it. And you get an OCI container out the other end. And the reason I want something that simple is that it gives us a path to binary container construction and reuse. And then we can do outputs and artifacts that say, when somebody says, hey, take this Docker file and run this, and you get a container, the same thing will apply to what comes out of a Octo build, and you could use those artifacts to do the same thing. That's the goal. And of course, this is something that I'm working on in Metavirtualization. It's in progress, and it's, I don't know, maybe 6 months to a year from seeing the light of day, but we'll see how it goes. Container deployment, it's not standardized, and my comment is it really shouldn't be, because how you deploy your container base is based, it matters how you're going to run it. So it matters on the runtime. What Podman runs, what Docker runs, what runc runs, what systemd nspawn runs, they're all different. So it's not super standardized, and we really can't standardize it. But some of the options to deploy using our definition of deployment is, direct image install, build, copy to a registry artifact, push it, and then pull, bring up Kubernetes, K3s, and then do a deploy from your build, and it will show up on the target. And there's a whole bunch of different custom hacks that you can do between the two. So those are some of the options. And I'm trying to build in ways to do all of the above without keeping in mind that we're not dictating the runtime and the build and many other parts that you could use to make something very specific. Container deployment, a challenge is it's really not cross-friendly, meaning, you'll see a lot of us have done things where you run Dockerd as a native tool, and you talk to it and you point its root repository that's going to be in your image, and you deploy to that, and you have the daemon write it out, but that has root requirements, host requirements, licensing issues, reproducibility, all kinds of things. They're not really cross-friendly. And a lot of the tools that manipulate container images do everything from file system creation, partitioning. Like, it's really easy to get into requirement creep. Like, they all want to fetch and build using something, a different process. Well, we have OpenEmbedded in Octo to do our build. We want to use that. I don't want it to pull from somewhere else and build a container. And of course, I said the large set of runtimes and frameworks is a challenge. I think we're going to be Not bad for time. Um, sorry, this is my upcoming work slide. So the vision, if you will. I'd like to position the Octo project as a first-class platform for building CNCF technologies, right? And it goes back to my slide where we can leverage the advantages of open embedded and technologies, and feed them into external solutions. So, that we can bake what we build directly into the outputs. We can ship all of those supporting manifests and licensing and everything along with it. So it would be ideal as when everybody else runs into some of these problems with their container deployments that, we kind of have our frameworks and we can offer something that's similar ease of use, but is using those open embedded advantages. And here's the one that I mentioned before. It'd be great to have a simple inherit to generate containerized recipe output. I don't want to have to rewrite a recipe or write two recipes per container. It should be something that we can almost configure in the configuration space and then be able to generate containerized recipe output. We want to mention, direct deployed images or a management framework to have some kind of integration with, directly with K3S. So you can then be able to have your own little CI/CD right out of the build that you can take an image and then you can sort of like QEMU runner and these things do. We can actually just push it to a container framework and do tests. Anybody who was at the Open Embedded Developer meeting knows we talked a bit about reference binary distros and things like that. So you can see something that I'm also driving at is that you should be able to find some kind of binary outputs in reusable base containers so you don't have to start from source for the very lowest levels of the container. Some way that you can build your part, pull in the rest of a base system that's needed to support it, and then deploy and still be able to get back to my first bullet point of leveraging all of the advantages of open embedded. So, that's the vision. And there's a lot of work between, that's 4 simple bullets, and there's a huge amount of work to do a lot of that. So I don't know when we'll get there, but that's where we're attempting to go. And I moved really fast, and I made it to the end. So that's pretty impressive. If there was any questions, we can do that for the rest of the available time.
Sure, there are 2 questions so far. Is there any technology to manage deployed apps in Docker images for updates, etc.? Probably Balena or something like that.
Yeah, well, it depends on what you mean. I mean, obviously, it depends on the runtime you choose. You can always do, like, we have all the CLI tools needed to manage, whatever it may be, to do a pull and update of a running container. That's all built out of Metavirtualization. It's all available. Plugging it into a bigger framework to automate it, you might start getting into integrating with some of the over-the-air updates or, different things like that, depending on how you've deployed to your target. So that's where I get into, hey, we want to work with the rest of the ecosystem. And it's tough to say exactly how you want to do it because of all of the sheer number of different runtimes. Like if you use K3S and Kubernetes, it's kind of baked into it where you redeploy your updated container and it takes care of all the details of killing the containers, bringing the new ones up, and doing the switchovers, right? So it's it really does depend.
And how are we, as in the Octo project, going to address this scary thing of Go dependencies? I know most of the Metavert stuff seems to need some sort of Go. I hope the
Yeah,
answer isn't vendoring.
no, well, I prefer vendoring over Go modding, so I have to turn it off right now. And yes, I seem to run into more than my fair share of Go applications, just given that a lot of the CNCF stuff is written in Go. We need to, we all know we need to do work on the Go fetcher to basically not replicate, but do what Go mod is doing, that does those fetches in a way that we can then plug into the rest of the fetcher infrastructure for mirroring, for reproducibility, and all of those things. But the way I've solved it in non-vendor Go recipes right now is literally tearing apart the Go mod file myself and cloning into place with their hashes. So multi-git repo source URIs, so I can clone into place the source that we need, but it's still using our the Git fetcher. So we do get back to having the fetcher doing the work, because the compile phase can't be reaching out and pulling things in, sort of period, if you want to actually vaguely have a reproducible build or something that you can do licensing and all the other things properly with. So the answer is in core with a Go fetcher, and that's easy to say and hard to do.
Did you want to jump in, Tim, on that? Tim Orling? Tim was replying to the question as well in Slack. So
I hope he said the same thing. Otherwise, he's right and I'm wrong.
That is so Canadian of you.
I argue behind closed doors.
Tim, you're unmuted, but I don't hear you.
I don't know how are we. Did we make it to the end of the time slot, or did I go so fast that?
You went so fast. You still have 7 minutes left in your time slot, and then there's a 10-minute break. So
yeah, we could talk about this all day. I did go very fast on purpose. I don't think that was me.
Tim. No, that was Tim. Richard's
Okay.
Purdy says he's looking forward to your fetcher patches.
Am I working now?
You are.
Yes.
Okay. Who knows what's going on with this headset? Yeah, I totally agree. Like right now, until we can get Go mod to be happening in the fetcher, it's a non-starter. And the problem is, like, if you look at the HashiCorp Surf recipe from MetaCloud Services, that was an example where, you know, I had used DevTool add to originally create the recipe, and DevTool is really good, or recipe tool is really good at going and finding all the files that look like it's a license file. And so, you know, my approach there was, you know, just purely from a licensing standpoint, not even from the source fetching and trusting things and everything standpoint, was to put, you know, the license checksums for all those files into an include file. But then how do you upgrade that? You know, now it's, yeah, it was easy to do it the first time when or quote unquote easy when I first created the recipe. But after that, now recipe tool needs to know how to look at the vendored files to look for recipe or for license upgrades and things like that. And also, you know, Bruce and I have both just battled poorly set up Go build systems. You know, like right now, I can't even upgrade that surf recipe because it totally breaks on something else, and I don't know why. So we really need probably to take a complete rewrite of the Go fetcher, unfortunately. But
and if anybody's that's listening, if their company does a lot of Go hacking, I'd love to talk to somebody that could give me the dummies version of how Go lays out those source directories, so I could understand when I get some of these build errors that we end up with, so we can figure out how to make it smarter to lay these things out. But yeah, like also, I said, the nerd control, Tim, has, like I said, 42 fetches in it, and it's literally going to be impossible to upgrade. So yeah, I'm kind of doing it as an illustration of how doomed it is once Go removes the ability to not build without, like, that's coming, right? So yeah, we are going to run slam into this eventually.
And if you look at, you know, Node or NPM, right, we discussed creating a recipe per dependency, but then you've got different versions for different recipes. And I had a project that had 100,000 node dependencies. So that would have been 100,000 recipes, which would have killed the parsing. So I think, you know, Bruce, like, to me, what I really want the most is like what you're talking about, the easy deployment mechanisms, and you know, getting it ready to go with K3s and things like that. The other thing that, you know, I'm struggling with is like, how do we do the layered containers, right? Or, you know, reusable based containers like you're talking about, you know, and use the container storage to actually, you know, create a layer on top, you know, inherit from, or, you know, from
Yep.
core image base, right? And then add the new things on top of it. And once we can figure out those two pieces in a really slick, or three maybe pieces in a slick way, the benefits of where we're going to be with SBOM and what we're already doing with, you know, manifest and licensing compared to what the rest of the industry has, like they don't even realize, because they haven't been sued yet. They don't realize how broken they are in cloud native. It's just because they haven't been sued yet.
Or yeah, or you go to some of the conferences and there's a lot of ad hoc, non-standardized solutions, and we can add some of our, you know, OE, Octo standardization around it, which would be better.
Yeah,
Yeah,
you know,
like I
nothing
said,
against you know, Belina and you know, Foundries IO and people like that are making a business of containerized OSs, but you know, we need that stuff not to be living off in their own GitHub repositories, you know, to be honest. Like the lessons learned and everything need to come into core or into Metavirtualization for the reuse of everybody. You know, I mean, again, I'm not trying to beat up on them, but it's just like that's the way my brain thinks about this, and I think this is the way that Bruce has been trying to attack this, is like, you know, do this in the spirit of OE, right? You know, leverage OE, leverage core. Don't do this in a new way.
100%. Like I say, I'm adding shortly. I just haven't had time to quite finish it. It's all in there. You'll see I added Unmaki as a host tool recently, so we'll be able to build multi-layer source containers that are OCI containers. But I want that ability to go to an artifact repository as well, right? So even that is only one step along the road. But yeah, but if I'll throw my pitch out, a great way to get a hold of us is do drop by the Libera, or I guess we're all moving off Freenode, but yeah, if you join us on one of those IRC channels, it's a great place to ask more questions on an ongoing basis or find out what's being hacked on.